Okay, hello everybody. We are recording. Before I pull up our PowerPoints for this week, I'm going to just tell you what I think the plan is and what my idea is because these lectures will be a little different than usual. The idea that I'm going for is that we're going to propose a question at the beginning, and then in this lecture, I'm going to offer one side of the opinion, and the next lecture, I'm going to offer the other side. And then for a discussion post, I'm going to ask you to choose a side. And so what I'm going to try to do here is offer the best case that I can for either end of things, knowing that in offering those cases, I am going to be slightly more extreme than I normally would be if I were presenting the case myself, because it's not my opinion that I'm presenting. I'm presenting in a lot of ways the opinions of others. And so without further ado, let me share my screen, pull up our PowerPoint for this week, and then we'll get going with things. So welcome to Ethics and Science. I don't have a fake lecture title for this week because I had to do that preface. So this is lecture 16, and this is going to be the case for the linear model. So in lecture 17, it will be the case against the linear model. And our meme for the day is modern problems require modern solutions, right? So what is the linear model? So this is something that comes out of Briggle and Mitchum and is very much the case in the Bush reading that went along with it. And the idea basically is that this is a model for the relationship between science and society, that scientists are accountable only to their peers. Scientists are responsible for producing good science. That also means that they're responsible for determining what makes good science, and that society then is responsible for putting that science to good use after scientists give it to us. And society also then is responsible for giving scientists the resources they need to produce good science. Breaking that down into the simplest possible terms, and honestly, too simple, it doesn't do great justice to the argument, but it's, in other words, money goes in, prosperity comes out. And if you're saying to yourself, wait a minute, I've heard this one before. Yeah, we've talked about this in this class already. This was the view of early modernism. And in some way, this is still the view that we have functionally. We'll talk about that in a minute. So this is the model put forward in Francis Bacon's The New Atlantis, where there's this, priestly strata of society where it's the scientists of Solomon's house. And it turns out that the people who live on that island, they just give the people of Solomon's house whatever it is that they need, and then prosperity comes out of there. It's purely transactional. And then this is also Descartes' project of mastering nature for the purposes of human flourishing. He says we should become masters and possessors of nature. How? By perfect reason, perfect science. So in this model, scientific progress leads to social progress and leads to moral progress. People would say, look, we have scientific progress here in the United States. We've developed these technologies where you don't need to be a farmer anymore, which means that you could do something like, say, be a philosopher, and then you can talk about ethics instead of working a farm your whole life. And new problems might be created, but science will solve them too. The big one that people point to in this model is the ozone layer. When I was growing up in the 90s, we were really worried about the ozone layer. There was a hole in it. We don't talk about that much anymore. Why? Because we developed better science and we closed the hole in the ozone layer. So, in this model, the rightful place of science is as totally independent from public influence, government influence, and private enterprise. Do we functionally do this all the time? Well, no, but that's where problems come in. We'll talk about that in a minute. And for this model, it functions on a particular form of consequentialism, which emphasizes good science as, accuracy of data. Things like unintended consequences are kind of downplayed. It's the immediate consequences that matter. And that might be a knock against that, but we might also say, well, look, the reason we downplay these unintended consequences are because they're solvable. That by the power of reason and science, every problem has a solution. And is this the model we have? Well, in a lot of ways, yeah. Things like military technology, which is publicly supported and operates independent of the public and in its origin, with World War II, did kind of operate independent of the actual military structure. These technologies developed by the military did eventually become civilian technologies. Things like microwaves, the internet, the car as we have it, because the modern day automobile is very different from the original automobile. We don't have wooden tires anymore. We don't have to crank it to start it. You can with some engines, but that's another story. And that, look, progress, our present way of life is, yeah, largely defined by technology, right? Like, I'm wearing clothes made by a machine. I'm speaking to you on a technological machine made of many parts from all over the world. It is for the last year defined my existence in ways that I might be uncomfortable with, but functionally, yeah, my life is defined by technology. And in this model, progress is, functionally speaking, our supreme value. What do we want? What are the things we chase after? The white picket fence, the house in the suburbs, higher standards of living. We do today have a much higher standard of living than people living 50 years ago. We have better access to things. Go back 100 years. We have refrigerators now. We have toilets inside our homes. My great grandmother grew up with an outhouse. She did not die that way. She died in a house with internet and flat screens and all these wonderful forms of technology that blew her mind because we have advanced. And these advancements in medicine kept her alive into her mid 90s. We don't have that kind of innings without scientific progress. And problems arise when we don't respect the model. That is hammered home again and again and again that this is the reasoning that is given by people who like the linear model for saying that, yeah, where technology goes wrong is, when like an authoritarian government gets a hold of it and says that good science is what advances our political ends, or when, say, religious institutions get a hold of science and say that you need to produce research that proves our theory of the origin of the universe, or something like that. And that if science were truly allowed to be detached in the way that someone like Robert Merton would want, then these issues wouldn't come up. That if there was just a hard barrier between science and the public, science could function on its own and then could give the public the things that they want from science. The model here is leave us alone and we'll take care of you. So, how would this model account for the big problems? Something like climate change or pollution, yeah, they have their source in unintended consequences. You know, Example would be plastics. We developed plastics for medical technologies and now they're polluting the planet. So, how do we solve it? Better technology. Maybe we'll develop some kind of bacteria that can eat plastic and produce oxygen. Then we can oxygenate the planet better. We have the technology. That's what people would say. And this is the view of the eco modernists, people who want to use modern science, modern technology, modern philosophy to help the environment because for them, the environment matters because it helps humans flourish. And the big group for this is the Breakthrough Institute. I've got their website here. They also have a book. Um, I will say, taking off the hat of advocating for this group, Breakthrough Institute's a little extreme. Putting the hat back on, that the Breakthrough Institute would say that what we have to do is, human progress is like a rocket taking off into space. And yeah, things are getting hot because we're approaching the atmosphere. And what do we need to do? We don't need to turn the ship around and crash and burn. We need to break through the atmosphere and then keep going into space. That's what they would say. And so in this model, something like the Anthropocene is seen as a positive. And I should pause here and explain what the Anthropocene is, taking a drink of water first. So the Anthropocene is a idea that came first out of the world of academic geology in a article put together by two guys named Cruzen and Stomer. And I'll link it to you. It's short. It's had a lot more influence than they ever intended. And the idea is that human beings have left a visible mark on the geology of the planet that in 1,000 years, in 100 years, or even presently, you can look at the geological layers and say, hey, this is where humans start to have a greater influence. Now, there is a lot of argument about whether, what exactly that date should be and the moral implications of those things. And I don't want to get into it now. You can take a whole class about it. I believe Dr. DeWolf is going to teach one soon. But the point is that folks who are for the linear model would say, yes, humans are now visible in the geological layer, and that is a good thing because it shows that we're taking control of our own destiny. And so there is a need to emphasize human potential, what we could be, what we want to be, and not our present or past failures. Instead of saying, well, we killed all these species. Well, yeah, but what could we do now that we know better is their idea. And depending on how you read him, Carl Sagan really fits this idea. He had all this really beautiful rhetoric about spaceship Earth traveling to the stars, improving our living conditions, realizing our potential as a species through the power of science. This is, in a way, the beliefs, the beliefs is not the right word, the philosophy of Carl Sagan. And so, specific problems, how would this model account for them? Climate change. Develop carbon capture technology. Create these devices that pull carbon out of the air and release oxygen so that the devices we have that are presently harming the planet do no harm. Or better yet, if you're concerned about, the gasoline engine, develop an electric one that's cheaper because if it's cheaper, people will use it. What about population growth? We don't have to remain on Earth. We can go to Mars. We can go to Alpha Centauri. Wherever it is that we want to go, we have the ability, right? What about human hunger? Well, we can develop better crops through genetically modified organisms. We're already doing it. We've been modifying organisms for a long time. Why don't we just do it better? What about loneliness? Oh, sorry. First, death of species. We don't have the woolly mammoth anymore, but we could bring it back through the power of cloning. And then, by the way, somebody can make a little bit of money because they can patent the gene. What about loneliness? Well, if you're isolated, say during a pandemic, we have Zoom. You can get these online communities that can fill that desire in the human heart. Water shortages, desalinization machines, machines that take the salt out of salt water. We don't need to go to war over water if we use the 70% of the planet that is covered in water for drinking water. We just need better technology. What about deforestation? The eco-moderns would say that if you want to stop the clear cutting of land for farming, well, you need to develop better things. And so they have a concept called decoupling, which is this idea that should we advance technology far enough, we can sort of, like two train cars together, decouple ourselves from the need to extract from the planet. Why would we want to do this? Because we're not going to limit population growth. You can't realistically do that. You know, there's no moral way to do that. And so we need to develop technologies that require less of the planet we live on. What about urban food deserts? Make vertical farms in those neighborhoods. You can build a tower of greenhouses that then can grow food for the people who live nearby. Whatever the problem is, there's a technological solution in this framework. And to some degree, global politics already operates on this model, right? We classify countries as developed and developing. And from previous lectures that I'm not wild about that idea myself, but there is perhaps some wisdom to it that, developed countries should be helping developing countries gain the things that we have because we enjoy them so much. Our lives are prosperous. We want others to prosper because we have basic empathy. Let's help them prosper. And when we invest trillions of dollars every year into developing nations, we do this for their flourishing and our own, because those countries then become trade partners. You know, if you like, say, spices in your food, you want the countries where those spices can be produced easier to have an easier time trading with you. This model would say that better science keeps us safe, it keeps us healthy, and it keeps us ahead of the curve. And so, whatever the problem is, Invest in science, and science will take care of you. And peace comes through mutually beneficial trade relationships and the products of science. You know, many wars are fought over resources. But if we don't need those resources anymore because we can produce better alternatives on our own, then we don't need to go to war for something. And so we can just mutually trade because we might want the things that they have and they want things that we have. And so we can just exchange and everyone benefits. Oh, and that's the end of the PowerPoint for that. So that is, largely speaking, the case for the linear model. Um, and I don't know, I don't want to offer any comment on my own opinions there. I do think that there is some good argumentation for the linear model. And certainly it is functionally a lot of what we do already. Anyway, I'm going to go record the next lecture, which will be the case against the linear model, and I will see you there. And